Hello, in this video I'm going to solve question number 7 from this past paper. Let us read the question first. A curve has equation y equals to 2 plus 3 times sine 1 over 2x for x greater than 0, greater than or equal to 0, less than or equal to 4 pi. Part A. State greatest and least values of y. If done correctly, this will bring you 2 points. Part B, sketch the curve. If done correctly, it also brings you 2 points. Part C, state the number of solutions of this equation, 2 plus 3 times sine 1 over 2x equals to 5 minus 2x for the same interval. If done correctly, this also brings you 1 more point. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you've done your calculations correctly, for parts A and C, you will get the following answers. For part A, you will see that the greatest value is 5, the least value is minus 1. And for part C, the number of solutions to that equation is exactly 1. Okay, now let us solve the problem. We want to find the maximum value for y and the minimum value for y. Okay, so here x is between 0 and 4 pi, but the argument in front of sine is 1/2 x. So if I want to know the interval for 1/2 x, I just multiply everything by 1/2, so it becomes 0 to 2 pi. Okay, so it means that this angle goes from 0 to 2 pi, which is one full circle. So it means that the sine function indeed attains its maximum, which is 1, and also attains its minimum, which is minus 1. So I know that I want to in order to maximize y, these two numbers are constant. This is the only thing that I can control. Okay, and I know that the maximum value of sine in general is 1, and that maximum is attained because the interval of the angle is from 0 to 2 pi. So it means that the maximum value of sine is attained, and it is 1. So it means that if I want to find the y maximum, I choose the maximum possible value for sine 1 over 2x, which is just 1. So it becomes 2 plus 3 times 1, and this is simply 5. And then if I want to find y minimum, I choose the minimum possible value for sine because these are two fixed numbers I cannot tamper with. So I have to minimize this in order to minimize y. And the minimum of sine in general is minus 1. But because of this interval, it really attains its minimum. So it means that the minimum value for y is when I choose minus 1 for the sine function here. And if you calculate that, it becomes minus 1. So yes, this is the maximum value, and this is the minimum value. Okay, now to sketch the graph, one thing that is good to know is the period of this function. So the period of this function, let us call it t, is 2 pi divided by this coefficient here, which is 1 over 2, so it becomes 4 pi. So this interval is exactly one period of this function. Okay, so this is just a normal sine function, but now multiplied by 3, so the amplitude instead of being 1 is 3, and then adding 2 will cause the graph shifts 2 units upward. So might be that's a good idea, try to sketch this part of the graph and shift it upward. Okay, so in order to do that, so I have this coordinate system which was given in the question to you, so you don't need to draw it. So then of course this is the standard sine function. I am concentrating on this part. So if x is 0, sine 1 over 2x is 0. So this is 1 point, and when x is pi, this becomes sine of pi over 2, which is 1 times 3 is 3. So it means here I will have that point. This is 1 point of my graph, and that is the maximum point because the amplitude of this part of the function is just 3. And then of course if I put 2 pi, then 2 pi divided by 2 pi, sine pi of 0, yes. And then of course I can also go down, because if I put 3 pi, then it becomes sine of 3 pi over 2, which is minus 1, so it gives me minus 3. So if this part is 3, I move it here, this becomes minus 3, and then this 3 pi will give me this point. And then finally, when I put 4 pi, it becomes sine of 2 pi, which is 0. So this function is a normal sine function. The only difference is that the amplitude is 3. Okay, so that's the graph of this part of the function. But now I add 2 units, so you know the effect of adding 2 units to the function is shifting that 2 units upward. So what happens if I want to draw it? So this means that this point will now be shifted here. This point will now be shifted here. This point, which was 0, now is shifted here. And this point will be shifted 2 units upward. So it will be here. And finally, this point will be shifted here. Yes, so I will have, you can imagine that this is a rigid object, you are moving it 2 units upward. So, of course, I cannot draw precise pictures. This should be identical to this black curve, but of course shifted 2 units upward. So then what happens here? We go up to here, and then finally we go there. Yes? Okay, something like that. Okay. So that is the green curve is exactly the curve that you are supposed to sketch. Okay, and the last part is that we want to solve this equation. We want to know how many solutions are there. Sorry, we don't want to solve it. We want to know how many solutions are there for this equation. Yes? Okay, so this means that if I have the graph of this function, and if I draw the graph of this function or sketch the graph of that function, the point or points of intersection will be the number of solutions, because the x-coordinates of those points are the solutions. The number of intersection points will be the number of solutions. Okay, so what we need to do now is to draw the graph of the line y equals to 5 minus 2x. Okay, one thing is, for example, if I put x equals to 0, because I know this is a line, I need only 2 points. When I put x equals to 0, y becomes 5. So let me go and find it there. This is this point. And then, for example, if I put y equals to 0, yes, if I put y equals to 0, or I can give, yes, y equals to 0 is good. And then x becomes 2.5. So this means that it should be at 2.5. Where is 2.5? Pi is 3 approximately, so 2.5 is before this point. Yes? And then, of course, I can draw this line and then continue this line. So you see that there is one intersection point between this dotted line, which is the graph of this line, and the green curve on this interval. Okay? So this means that there is only one solution to this equation. Okay? I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.